All right. Welcome, everybody. Thanks for being here. We got a full house tonight. Some familiar faces, but for those of you who I do not recognize, the way we do this is we will talk up here for about 30 minutes or so, and then I'll turn it over to the audience for question and answer. So, got a lot of you, so I'll give a little bit more time to that tonight than usual. But yeah. So tonight we have Dr. Clark Alexander. He's the director of the Skidaway Institute here, and he's a professor in the Department of Marine Sciences at UGA. He earned a bachelor's in oceanography and a bachelor's in geology from Humboldt State, and a master's and a PhD in marine geology from North Carolina State. He joined the Institute in 1989 and was promoted to director in 2017. He is a coastal and marine geologist who focuses on coastal resilience, sedimentary processes, and marine resource mapping. He works closely with local and state governments and agencies to address pressing coastal management needs. Welcome, Dr. Alexander.
So, first question on your minds is coastal geology. What am I talking about? Marshes. Well, that's a really interesting question, and the short answer is that when you look at how the coast works here in Georgia, and those of you that have heard me talk before, see that everything is interrelated. So you can't really just look at the sediment itself. You have to look at how the sediment interacts with the vegetation, with the physics that moves it around, and so over the years, there's been a large long-term program based out of Sapelo Island that's been examining salt marshes and sort of as a type area for studying salt marsh ecosystems. That's a long-term ecosystem research program. It was started back in 2000, and so that program went on for 26 years. And so it's a group of people that work closely together, and as we each other, we learn about how our science impinges on other sciences as well. So over 26 years plus work that I've past, I've gotten a deep education from my colleagues about salt marshes, how they function. And then there are some questions about salt marsh resilience. So as I was saying, so there's been a lot of physical issues that directly impinge on how our marshes are going to persist into the future, when our marshes could have formed, and we'll talk about that in a little bit. And then there is modeling that's been done looking at the interactions between things like sea level rise and sediment input and changes in sediment input, and the ability of the marsh to accrete sediment and build itself up as sea level is rising at the same time. And so there's all these very interesting interconnections between biology, geology, physics, and chemistry as well, although that's not as important in the things we're going to be talking about tonight. So with that background, I do want to just briefly touch on what's going on down the road, because I've had a number of questions. And that is, back in the mid-1970s, these were all open fields that you see clear-cut now. This had been a working cattle ranch where they bred Black Angus cattle up until 1967. And as the Institute was growing, we were finding we were spending a lot of effort keeping those fields mowed and cleared and in a way that wouldn't lead to wildfires and things like that. So we wanted to do something instead to increase the habitat here on the island. So we worked with the Georgia Forestry Commission to plant pines, which is something that we know very well here in Georgia. And so that was in the early 80s. We did a first thinning of those pines in 2021, and this was the time now to do the last, which looks and is called a clear cut, which is basically the other half of the timber. The goal is to do a controlled burn and then replant with longleaf pine, which is a favored species here along the coast of Georgia, very native to the area, probably was on this island at one time as well, and replacing the loblolly pines that had been planted, which are a very quick growing but not preferred species here on the coast. So that's what's going on, and we'll be doing that replanting next year, probably in the winter after we do the controlled burn. So just wanted to let everybody know what's going on, because I know there's a lot of interest about that. So if you have any people that ask you, now you can tell them. It's kind of like that shampoo commercial, right? Tell a few friends. And yes, ma'am. That, as I understand it, is necessary to kind of prepare the whole area for the replanting of the new pines, kind of to knock back species that might grow. So we go through one growing season before the controlled burn to sort of let the weeds and the unfavorable things, like there's lots of Chinese tallow out here. So we're trying to knock those things back before we replant. Okay, but back to salt marsh. Sorry about that.
Yeah.
But thank you for your indulgence.
So to start it off just broadly, why are marshes so important to this area, both environmentally and economically?
Yes, well, this is the kind of answer I should ask for people in the audience to tell me, because these are things that we all fundamentally know, I think. You know, we know that marshes are important for protecting the uplands that they surround, right? These marshes, they knock down wave energy, both on a daily basis, but also during storms. So we're able to look to them as a buffer between water that might cause erosion of the shoreline and the channels themselves. They're also important from a number of other physical reasons, and one of which is that those marshes, as we've already talked about, and which we will talk about more in depth, they are vast accumulators of fine-grained sediment. You know, fine-grained sediment's great, but it also tends to adsorb any contaminants that are in the water. And so we don't really want those things being moved around within the environment. We'd much rather them to be sequestered into the marsh, be buried in the marshes. So they lock away contaminants. They also have the effect of absorbing and then more slowly releasing floodwaters when we have high water levels. You know, you probably have seen at low tide, you know, water slowly draining out of the marsh. So marshes are good temporary sponges. And then, of course, there's the biological factors, as many of you have heard, I'm sure, that these marshes play a significant role in some part of the life cycle of many of the species that are important here in Georgia. You know, crab, shrimp, many of the recreational fish species that we all love to go and fish for. So they are also important from a biological standpoint.
So,
one more thing.
yeah, sure.
And economically, and sometimes I forget about this, is that economically, that these marshes, these very pristine environments that we have here in coastal Georgia, are very important engines for tourism, ecotourism, charter captains to take people out fishing, kayak tours that take people out into the environment, naturalists. There's a whole program that the Georgia Sea Grant is running now that has been training guides and teaching people about responsible trip leadership for ecology tours, things like that. So there are a lot of important economic reasons why our marshes are important, simply from an aesthetic standpoint. And then, of course, there is the aesthetics, which all of us appreciate, I think. I really love that I get to drive out here every day across the marshes, and just a small moment of zen before you get to work and the day starts. So it has a number of different impacts, both economically, biologically, chemically, and aesthetically to the people of Georgia.
Is there anything that makes the marshes in Georgia unique compared to other marshes throughout the country? What differentiates them?
Well, there are a couple of things that make our marshes, in my mind at least, significantly different than the marshes that you see in other parts of the country. Particularly within the southeast, we have dominantly Spartina alterniflora marshes. You've all seen that grass out there in the marsh. These marshes, if you think about, if you've ever been to the Outer Banks at North Carolina, if you've ever been down to Florida, and you've been to northern South Carolina, those typically they've got little fringing marshes. I like to call them boutique marshes. Uh, but here in Georgia and southern South Carolina, we have plenty of sediment in our system. Our marshes basically fill in our back barrier environment. And so that's one of the major differences. And of course, many of you have heard the statistics that Georgia has about 360,000 acres of salt marsh. And within the Southeast, we have about 30% of all the salt marsh that we have in the United States. So it's a significant portion of a very critical kind of habitat.
So, what are some of the threats that our marshes are facing, specifically in coastal Georgia right now?
Yes, so we talked or alluded to some of the external factors. One of the major factors is decreasing sediment supply to the coast. Back in the 1700s, maybe early 1800s, we had free-flowing rivers that delivered a lot more sediment to the coast than they are today. A lot of that has to do with damming some of the rivers. So, for instance, particularly the Savannah River used to be a significant source of sediment to the coast, and has basically stopped supplying sandy sediment to the coast, although there's still some fine-grained material that makes it there. So decreasing sediment means the marsh has a harder time trapping sediment because there's less sediment to trap, and they're less able to build up. And that goes hand in hand with rising sea levels. Those of you that have heard me talk before have heard me talk about sea level, which is rising here along the Georgia coast at about 3.5 millimeters per year. And so we would hope that our marshes are also building up at 3.5 millimeters per year. And we'll talk about that later, and how those numbers are comparing what the reality really is. So there's another factor that is a natural factor, which we really didn't have a good handle on until relatively recently when we had new techniques for measuring it, and that is subsidence. We have heard about over withdrawal of groundwater, how in some areas, like in the mid-continent US, that's caused subsidence of feet, multiple feet, where you've withdrawn groundwater. The story isn't as clear along the east coast of the US, but we do see that there is some subsidence going on. And of course, if sea level is rising and the land is sinking, that exacerbates that rate of rise. So the marsh is sinking while the water is rising as well. And so that is something that the marsh needs to overcome. So those are natural effects. There are also, things that we do. We already touched on damming rivers, so we provide less sediment for the marshes to be able to sequester. We also do things like pave over the land surface or build bulkheads, things that stop the land surface from providing sediment to the marsh as well. So we're decreasing sediment input both from the upland adjacent to the marsh, but also from the rivers, which provide sediment that will then be sucked into the estuaries with the coming and going of the tide. And then, of course, also paving over the landscape causes flashier discharge, which can harm the marsh by bringing in more fresh water relatively quickly that it's not necessarily adapted to. So there's a number of factors that are threatening the marshes over time, and we'll talk a little bit more about some of those in a minute.
Right. So, how do scientists like you and those in your lab predict the future of our marshes? Can you talk about your work a little bit?
Sure. Before I go into that,
Sure.
what's my second slide out there?
Let's see.
Oh yeah, look at all that marsh, right? This was I just wanted to point out, and this goes to the history of our marshes earlier, and you can see along the Georgia coast here, right? We've got barrier islands, and then we've got the mainland, and then we've got this sort of grayish, reddish looking stuff. And that's all salt marsh. So, you know, we were talking about how our back barrier environment is basically full of marsh. And you can see that in this image as well, particularly in the middle panel. What I want to draw your attention to is the panel on the right, which shows that we have multiple ages of barrier islands here, right? So there are ones that are in black, which are very young. We know those islands from dating them are less than 500 or 600 years old. And then the islands like Skidaway and Wilmington Island, and you can see they're in a different color, but that is a different barrier island chain, which was formed maybe 100,000 years ago. So if you think about that, think about the islands that are now barrier islands, the young ones, they didn't exist 600 or 700 years ago. So there was no back barrier environment for marshes to start forming in. And it's only been within the last 2,000 years that we have seen the coast prograde in some areas, like this whole area here. You can kind of see the distance increases between the young island and the old island here. And all that marsh has been formed in the last couple thousand years. And so that was when we were having sediment supplied to the coast. That sediment was being trapped. Well, the sandy sediment was forming barrier ridges. And as those ridges were formed, there became quiescent environments behind them where the mud could settle out, the marshes could start to grow. And if well, I should tell you because I didn't show you my sea level curve, but about 4,000 years ago, sea level was about 3 feet lower than it is today. And so, you know, where we had the oceanfront barriers, you know, water was lower. And so we probably over time have filled up those areas, and salt marsh has been able to grow in, and because it's a more quiescent environment. And so our marshes could only form after we had our barrier islands forming. So we've had marshes for the last couple thousand years. We've talked a little bit about what's important about them now, and then now we'll talk about how we
Yeah, I was
what's going to
asking.
happen in the future.
Right, exactly. How
Mhm.
you predict the future, what's
Yep.
going to happen to these marshes.
Next slide, please.
Sure. And if you want to control it, all you got to do is these two.
Now we don't. Oh, how'd that get in there? All right, keep going.
All right.
Well, keep going. Gosh, sorry about that. I had this planned out different order in my mind. So, which is funny because I put the questions in the order that I thought they made more sense. So one of the major things that people are doing today is developing models to try to predict what might happen in the future with sea level rise. And the most commonly used one is called the SLAM model, the sea level affecting marshes model. And it is relatively simple because we know what salinities and what elevations in relation to tide level are different kinds of marsh species are found. We know that, for instance, the Spartina marshes, we find those Spartina grasses between the mean tide level and mean high water. So they don't really go down into, areas that we see as mud flats because they're underwater too much of the time. So what we see is, if we can say where the plants are in relation to the tide range, then we can look at the slope of the land. We can say, well, if sea level goes up a certain amount, here's how much the land water boundary will move inland, and that is where the marshes are going to move. That's the basic idea. And then they do it for different plants that have different salinity tolerances and different locations in relation to mean high tide. But what this figure behind you is showing is the initial condition when the last time we ran this for the Georgia coast, which is in 2019. The initial condition was based on aerial photography and distribution in plants in 2007. And that's why it says that there on the screen. And what I want you to see is that there are, within those yellow boxes, there are changes in the color of the kinds of plants that you see within those boxes. Now, I know it's kind of hard to see. I've drawn arrows to the most important kind. Lost my thing. To the most important kinds of plants that we're concerned with. The salt marsh, as we know it, the Spartina salt marsh, is called regularly flooded marsh, which is those green colors in the middle there. And that's what you see filling in basically from the barrier islands right now to the mainland, right? That you can kind of see that color. And I don't really want to get up, but yep. And so what I want to draw your eye to is a couple things. So if you look at the Ogeechee River, the second yellow box down, you'll see that whereas there is a good bit of, in the upper left corner of that box, there's a good bit of darker colors, which represent tidal freshwater marsh and cypress swamp. If you look in the 2100, so this assumes a 1 meter rise in sea level by 2100. If you look at the upper right of that same box in the later time period, you'll see that now we've lost a lot of that tidal freshwater marsh, and we see much more of the brackish and the salt marsh in that box. The other place you can see it very well is in the St. Mary's River, because the St. Mary's River doesn't have much river flow, so there isn't very much fresh water to dilute that salt water as sea levels rise. And you can see there in the left half of that right box, you can see there's lots of cypress and freshwater swamp, and then you've lost all of that pretty much with sea level rise. So the important take homes from this kind of modeling exercise are, if you have a lot of freshwater discharge, you can kind of fight back as sea levels are rising, as salt water is trying to intrude and trying to change the environment from a freshwater environment in the upper reaches of the fluvial system to something that is saltier. Okay. The other thing that's important to realize is, as you can tell here, those river valleys, we have our big wide marshes, and those river valleys narrow as you go upstream, right? Kind of see that. And so that means that as salt marshes intrude further and further up these fluvial systems, we will have more salt marsh, but we will have less freshwater marsh. We'll have less brackish marsh, because they get squeezed out as there's less floodplain and less area. So those are the kinds of insights that these models give us, and they allow us to predict where we think. And we can also predict, of course, because we're looking at where the water is meeting the land, we can also predict which areas of upland are going to transition to intertidal areas. So those sorts of data can be used for, municipalities, for planning, for change in areas you don't want to develop. The other important aspect of that is there are only a few ways that salt marshes can keep themselves in the tidal range that they want to be in, right? We talked already about building up sediment to get thicker and thicker. And so you can keep growing on top of that and keep yourself within the intertidal zone. The other way you can do that is to migrate onto the upland. As sea levels rise, you stay within that intertidal zone and move onto the upland, and you get higher in elevation that way. You don't build your own elevation, you use the elevation that's available to you. And so these kinds of results that predict which areas are going to be transitioning and when and how quickly are important for coastal managers, because you really don't want people to be building bulkheads and blocking the pathway for all the marshes, because if you start doing that, what that does is the marsh no longer can migrate onto the upland, and if it can't build up fast enough, then sea levels rise more and more. The marsh stays at the level when it reached the wall or the bulkhead, and then over time it gets drowned out. So that's something called coastal squeeze, which is leading to loss of marsh. Even right now, we see the effects of that. And so coastal managers are really trying hard to maintain marsh migration corridors where marshes can migrate over time to preserve their ability to maintain themselves.
Are specific areas of the marsh specifically more vulnerable than others? I mean, you spoke about that a little bit, but can you go into a little bit more detail about that?
Would you go back one slide?
Sure. If you want, you can take the wheel too.
Oh, I don't want to.
All right.
It's good to be the king. So we've talked about sea level rise and the impacts of sea level rise, and we've referred again and again to the ability of the marsh to keep up with sea level rise. So we've recently finished a project. The figure on the left shows the layout of about 120, well, what did I say, 120, yeah, 126 separate cores collected from the salt marshes in Georgia. We use a dating technique called lead-210 geochronologies, which allows us to calculate the accumulation rate over the last 100 years. So that, that's kind of perfect for looking at how fast have our marshes been keeping up while we've been active in the coastal zone. And what you see on the figure on the left is the location of the cores, and then the colors there are color coded by rate of sediment accumulation. The average there is about 0.26 centimeters per year. So 2.6 millimeters per year. We've already said that sea level rise over the last 100 years has been about 3.5 millimeters per year. So from that, the general evidence of the core studies, they tell us that our marshes are not keeping up with sea level rise. And over the last 20 years, there has been an uptick in the rate of sea level rise. So it's probably twice what the historic rate has been. So the rate is now something on the order of 6 or 7 millimeters per year. So our marshes are definitely not keeping up, and so they will not be able to build up fast enough to keep above sea level rise in the future. Now, there's been some work in the last 5 years that shows that our marshes sit very high in the tidal frame in relation to mean high water. And so that kind of provides a little bit of freeboard for our marshes. So they're not going to disappear anytime soon. And it gives them a little bit of elevation that sea level can rise up for a while before we start seeing loss of marsh. And And when people have kind of modeled those kinds of time scales, what it tells us is that if we only get a meter of sea level rise, which is kind of what is being predicted for the end of the century, our marshes should be okay. We shouldn't have whole scale marsh loss. If we have 2 meters of sea level rise, however, which is the high, we keep conducting ourselves in the profligate way of emitting CO2 that we are now, that the marshes are pretty much toast by the end of the century. So there's a lot of sensitivity to how much sea level rise we have by the end of the century.
So if that is the scenario, what will happen? What will our environment look like without our marshes?
Well, I'm sure a number of you over the years have driven by areas that either have had large deposits of wrack on them so that all the marsh grass has died underneath, or if you've been and lived here long enough, there was a number of years driving up and down I-95 just south of us here. There was a big marsh that had a die off for an unknown reason that we've never been able to determine. But you could see, all the grass was gone. It's just an intertidal mud flat, and that's really what we would have to look forward to. And not saying that that's necessarily a bad thing, because there are lots of things that like to live in the mud.
Mm-hmm.
I mean, birds love to feed on things that live in the mud, wading birds. But there are a number of different species, as we already spoke about tonight, that need these marshes as part of their life cycle. And so it would be pretty disastrous for our ecosystems as they stand right now.
Right. Before we turn it over to question and answer, I just have one last question.
Mhm.
But are any of our government systems, state, local governments, working to prevent this? And what kind of work are they doing, if so?
Well, certainly, many people here are probably familiar with the Georgia Department of Natural Resources, the Coastal Resources Division. There was a law passed in 1970, the Coastal Marshlands Protection Act. That was very ahead of its time, and it serves to protect the marshes in Georgia, and really doesn't allow large scale activities in the marsh without going through the marsh committee, which has to pass on large projects which impact typically less more than an acre of marsh. So Coastal Resources Division is the staff to that committee, and so they're working every day. And I can tell you they really do care, and they really try to apply the law fairly and equally to everyone. I served 10 years on that committee, and so I saw the bad projects that they try to show us why they're bad, and the good projects that they try to make even better over time. So through the state, there's a very active program working there. Then also there is a larger scale initiative. I see your hand. I'll get it to you in a second. There's a larger scale initiative that has been started back in 2023 called the South Atlantic Marsh Salt Marsh Initiative. Thank you. Which is basically a Pew Charitable Trust initiative that is has a goal of preserving 1 million acres of salt marsh within the southeast by 2030. Is that right? Yeah. So there are some larger scale initiatives going on, and the SAMC program, I will say, has been very, very active in Georgia and throughout the southeast. And Mark, does Michelle, is she the sort of lead on that?
Georgia Conservancy is leading that effort in Georgia. They haven't said that different organizations still have.
Okay, thanks. So if anybody wants to know more about it, that's Mark Reese. He's the director of Georgia Sea Grant. He can tell you more. All right, thank you, ma'am.
Fouling,
Yes.
also discharge from ships. The East Coast does not have any state laws that I know of, except for Georgia, whereas on the West Coast, California, Oregon, and Washington do. We are not really monitoring that process, and invasive species are easier to come into contact with our marshes, which is very dangerous for our ecosystem. And I was wondering if there are any efforts to try to change that so that we do have more oversight as to what these ships are distributing into the Savannah River, for instance, as far as being a little bit more proactive and making sure that we're doing inspections and that they have proper filtration systems like they do on the West Coast.
First eclipse that I need to be quiet. Okay.
I am not personally aware of any efforts, that are going on, actively right now but, I know that the Georgia Ports Authority is working very hard over the last couple of years to, initiate, or get us, sort of a clean marina certification. That is, something that many ports around the country are trying to do. I don't know, Mark, do you know anything about ballast water discharge efforts?
No.
Okay. Yeah, I'm from California originally as well, and I am aware that they pay a lot more attention to that issue. Georgia's Sea Grant and the Shellfish Research Lab here has monitored some of the invasives from ballast water at different times in the past, but I'm not aware of any concerted program to track them.
Next.
Yes, everything.
I think I remember reading or hearing that the Georgia government, the legislature, is considering an amendment or a law to repeal the 1970 Marsh Protection Act, whatever it was called.
Mhm.
Is that true, and is it a real threat?
I have not heard that, and I talk with folks at Georgia DNR pretty frequently, so I think I would have. So I don't think that's true. Now, every legislative session, someone wants to open up the law and make some changes. So like the Shore Protection Act, which came in 1979 after the Marsh Act, there were some changes made about where you draw your setback line from the dunes a few years ago. And so those things do happen, but the Coastal Resources Division is very hesitant to go in and make any changes because you never know what will happen when the law is up for consideration. And so they'd rather not make any changes at all. But I have not heard that, so.
Yeah, it's reassuring.
Yes.
Hi, good evening. I know that there are different projects going on for living shorelines so that the marsh can continue to move up as sea level rises. We're going to one in Midway. I think Georgia Conservancy is doing a volunteer project where we're bagging oysters and laying them down so that it can create a natural barrier to prevent erosion.
Mhm.
So I'm just wondering, does SKIO do those kinds of projects here on the island? Can you talk a little bit more about living shoreline? Are we pretty good with our development here in Skidaway having living shorelines, or are there projects to do more of that?
Well, there's a couple answers to that. One is that living shorelines is a relative newcomer to the coast of Georgia. We've only had some demonstration projects that were installed on Savannah Island 20 years ago, and they've been monitoring them. And how you build them, what's an appropriate way to build them has changed dramatically. There are now a couple companies actually that are in business to do that, whereas 5 years ago there wasn't anything like that. So what I will say is that living shorelines are always something that people consider now, whereas they weren't as much on people's radar. And so I wouldn't say that, everywhere along Skidaway Island, people are putting living shorelines in, but I know we've been doing some work on our bulkhead, and I've been working directly with one of the companies that does living shorelines to talk about what would it take for us to install a living shoreline instead of just rebuilding our bulkhead and changing how we're protecting the uplands. So I think it's getting a lot more attention and it becoming more normalized as it becomes a routine thing.
I just want to add something that as recently as yesterday, I participated in a Georgia Sea Grant initial planning session. And I think you talked to the landings some time ago.
Yeah.
Put the landings in touch with Sydney at Georgia Sea Grant. And so there's now a project.
The resiliency person for Georgia Sea.
And so there's a project that's about to begin. She's doing some interviewing residents to hear what they're concerned about. That meeting raised questions about plants, birds, what we love, or why we want to keep that. Initial planning session, so it's early, but the project is supposed to end up with some recommendations for some things, some demonstration projects around the landings. And then someone else at the aquarium is tasked with providing resident programs to teach people what we've learned from that. So stay tuned, and if anybody's interested, let me know if you need volunteers.
Yeah, just reinforcing that there's tons going on right now as these things are becoming more and more common. Anyone else? Paul?
Could you tell us a little bit how you see your role has changed in defending the marsh over the years? What goes on personally for you?
Well, a lot of it has changed as I've learned more, you know, because when you start out, it's like, I want to protect everything, you know, nothing can change. I want to protect it. And that's just not realistic. You know, so the more you learn, the more you engage what is important, what is critical. How do you take a project that is going to impact the environment and how do you make it better? And so you have to start to balance, and I think you may have read that here, you know, that as I served those 10 years on the Marsh Committee, it became very clear that you have to learn how to operate within the constraints of the law, because you can't just throw up your hand and say no. And it wouldn't matter because it started out with 3 people on the committee, and now I think there's 5 plus the commissioner. But it wouldn't matter because, you know, if everyone else wants to say yes, so the best thing you can do is make it a better project. Say yes, but this needs to happen, you know, because this isn't going to impact the project, but it makes it less impactful, or it makes it a better, or there's more shared pain in making sure that things are done in a accurate way. That's going to be more beneficial than detrimental. So I think that's what I would say is as you learn more, you learn how to balance things better.
Well, I do remember in your 10 years on that committee, you got a few bumps on the head, but you made it better.
As somebody who's moved now from the Midwest to Georgia, I'm new down here, and I also live inland. So this is very eye-opening to me. And I'm just very curious, how do you become a board member? Who chooses who is on the board?
So it's an interesting process. Basically, the committee as it's set up right now is everybody has 3-year terms. They're rolling terms. So, you know, one person is rolling off every year. There is a call for interest from the general public. To serve on the committee, you have to be a coastal county resident of one of the Georgia coastal counties. And I don't remember what the other thing is, but it's a pretty low bar. But then you submit your name to the DNR and they gather, you know, everyone's kind of statement of why you're interested in your qualifications and your background. And then that all goes to Atlanta to the DNR board, who are all political appointees. And then they decide who gets appointed to the committee.
Time for a couple more here.
Let's see, there's
I work for a municipality and we are about to embark on a resiliency study. Primarily because FEMA is freeing up some funds so that we can gauge the impact. We know the impact that increasingly harsh storms have had. And so we're trying to use our natural resources to maybe absorb some of that to lessen the economic impact to people who live in these areas. But what should we be mindful of as a municipality from a scientific perspective, you know, as we're looking to engage our natural resources and enhance some of these features? What should we inject into our study at these early stages that would be helpful?
And are you in a coastal, are you?
Yeah, Bluffton, South Carolina.
Oh, okay. Yeah, so you certainly want to consider sea level rise projections. You know, that's something that Chatham County Commission only started thinking about 15 years ago. You know, prior to that, sea level was where it was. So you need to be thinking about that. You need to be thinking about your stormwater systems, you know, because this compound flooding that we get now with high tides and these higher rain rate events that we see, you need to think about that. You also need to think about your vulnerable populations, of course. You know, how do you evacuate them, and then think about how you make yourself more resilient, whether that is from building new salt marshes, new bagged oyster shell reefs. There are also hard materials that sort of mimic reef materials that attract oysters better, because a lot of times there's a limit on shell that you can get these days. So there are alternative materials to think about. And of course, South Carolina has been very good about working with their oyster restoration program. So that would be a great partner to get in touch with. Mm-hmm. Yes.
Is there a relationship between the tidal range and the amount of marsh that you have in a given area?
Yes, absolutely. Because we have a high tidal range, there's a large area that can be intertidal. And the more area you have like that, and more sediment to be able to trap and fill in, that's really why our marshes are so extensive behind our barrier islands. You know, up in North Carolina, as a contrast, you know, they've got a tidal range like this, yes. You know, and so that's why you end up with these thin fringing marshes just on that little area that goes in and out of the tidal range.
Those are the boutique marshes?
The boutique marshes, yes.
Is there one more back there in the back?
My question is kind of related to that. How adaptable is Spartina? So if the sea level rises, does Spartina just grow taller? So it still can be above the water?
There are certain limited adaptations that Spartina can make, but not really anything significant to help it, because the plants need to be out of the water some of the time as well. So if most of the plant is under the water too long, it dies off. And this is an important point I forgot to mention, that there's some very recent research in the last 6 months, which suggests that looking at what's above the ground, you know, because we have above ground biomass, right? All that grass usually sticking up. And then there's almost as much, if not more, carbon in the mud, the below ground biomass. And the work that done recently suggests that even though the above ground biomass looks nice and healthy here in the southeastern US, that the below ground biomass seems to be declining. And whether that's a temperature signal or a nutrient signal or something else, we're not exactly sure yet. But it looks like there are early warning signs that things are happening to the marshes that are not visible to the eye.
I saw one more hand, so let's ready.
Yeah, sure. I have kind of a pie in the sky question. Recently, we saw the Klamath River restored for salmon, which was amazing. But what if these rivers feeding the coast were allowed to flow naturally again? Would that build enough sediment to fight off some of the water rise?
Well, it would certainly start providing the sediment it used to provide. Now, there's some question because there's some theories that, it was row crop agriculture, in the, very early 1900s into the 1940s that delivered a lot of sediment to the rivers, kind of clogged them up. And so that the historic rates of sediment input were not that high. And now, of course, we have better agricultural processes and we do better farming. So we're not as, we're not discharging as much sediment soil into the rivers. So there's some question whether just restoring the systems would get us to something where the marshes would be well restored, or whether there still wouldn't be enough material.
All right, well, thank you to Dr. Clark.